Welcome back to a new session of MOOC on Information Security. Today we will discuss cryptography. The objectives of this module are to define cryptography, to understand the importance of cryptography in network security, and to discuss different types of cryptography. Cryptography is one of the strongest tools to control different attacks possible to security of information. It is a way of secret writing or disguising data to avoid reading, modifying or fabrication by some attackers. Cryptography has its roots in higher mathematics. Group theory, computational complexity and real analysis provide an efficient way to encrypt and decrypt the data, and probability and statistics help to identify the different possible ways the data can be disguised. But don't worry, you need not have to be good in mathematics to understand and use cryptography. Let's start with the two simple basic principles of encryption methods such as substitution and transposition. These methods need to be improved to create stronger and more sophisticated protection. We also need to analyze techniques used to break these protective schemes and reveal the original text. The word cryptography means hidden writing and refers to the practice of using encryption to conceal text. Anyone studies encryption and encrypted messages expecting to find the hidden meanings are called a cryptanalyst. A cryptographer and a cryptanalyst attempt to translate coded material back to its original form, but in different perspectives. A cryptographer works on behalf of a legitimate sender or receiver, while a cryptanalyst works on behalf of an unauthorized interceptor. The study of encryption and decryption is called cryptology. Before going further, we need to understand some basic terminologies used in cryptography and related algorithms. Terminologies. Just assume a situation in which A sends a message to B. Here, A is the sender, B is the receiver or recipient. If A assigns the message to T, who delivers it to B, then T is the transmission medium. If some outsider O tries to read, change or destroy the message, O is called an interceptor or intruder. The vulnerabilities caused by O to the messages transmitted to B from A through T are: block it by preventing its reaching B, affecting the availability of the message, or intercept it by reading or listening, affecting the confidentiality of the message, or modify it by accessing it and changing the content, affecting integrity, or fabricate an authentic looking message which also affects integrity. Hope you now recall the CIA triad we discussed earlier. Confidentiality, integrity and availability are the three pillars upon which an efficient information system is constructed. Hence, these security failures must be addressed seriously. Encryption is a technique used to address all these problems. The most fundamental building block of secure computing is encryption, which is a method of maintaining secure data in an insecure environment. The basic terminologies to be understood while learning cryptography are: encryption, a process to encode a message so that its meaning is not obvious. The terms encode or encipher are also used for the meaning of encrypt. Decryption, the process of transforming an encrypted message back to its normal. The terms decode or decipher are also used for the same purpose. Crypto system, a system for encryption or decryption is called crypto system. Plain text, the original form of a message is known as plain text. Ciphertext, the encrypted form of a message. A plain text message P is denoted as a sequence of individual characters as P equal to a collection of P1, P2, P3, etc. Pn, and ciphertext as C equal to a collection of C1, C2, C3, etc. Cm. For example, the plain text "You are awesome" can be denoted as the message string consisting of the letters of the string U, O, U, A, R, E, including the white spaces. It can be encrypted to a ciphertext which is C1, C2, C3, etc. C15, and the encryption algorithm is responsible for the transformation. The formal notations to describe the transformations are C equal to E of P and P equal to D of C, where C represents the ciphertext, E is the encryption rule, P is the plain text, and D represents the decryption rule. Hence, it is important that when we encrypt a message to protect it from attackers or intruders, we should be able to get the original message back at the receiver side to read it accurately. The encryption and decryption of the plain text is given in the figure. Encryption algorithms. The crypto system involves a set of rules for how to encrypt the plain text and how to decrypt the ciphertext. These rules, called algorithms, use a tool called key denoted by K, and hence the resulting ciphertext depends on the original plain text message, the algorithm and the key value. This is denoted as C equal to E of K P, where E is the set of encryption algorithms and the key K selects one specific algorithm from the set. There are also keyless encryptions like Caesar cipher, but keyed encryptions are more difficult to break. Just think of a situation like you are going to buy a lock for your house. What are your concerns in this case? It may not always be possible to have a contract with someone to invent and make a lock just for your house. So, a better solution, you would go for some well-known, well-respected companies producing standard locks that differ according to the physical key. So, you and your friend will have same model of lock, but your key will open only your lock. In the same way, we need to have a few well-examined encryption algorithms that everyone can use, but have differing keys that would prevent someone from breaking into what you are trying to protect. Sometimes the key used to encrypt and decrypt will be the same as P equal to D of K and E of Kp. This is called symmetric key encryption because D and E, that is decrypt and encrypt, are mirror image process. Some other times encryption and decryption keys come in pairs. Then a decryption key Kd inverts the encryption key Ke, so that P equal to D of Kd and E of Kep. This type of encryption algorithms are called asymmetric because converting C back to P involves a series of steps and key that are different from the steps and key of E. The difference between symmetric and asymmetric encryption is depicted in the figure shown here. In the symmetric crypto system, same key is used for both encryption and decryption. But in the case of asymmetric crypto system, the keys are different. Importance of cryptography in information security. Usually, cryptography is a term coincides with information security. This is a way of ensuring secrecy, consistency, identification and non-repudiation among other information security goals. Cryptography protects the confidentiality of information. Protecting the privacy of users whose sensitive information is maintained demands confidentiality. Encrypting is the only method of securing the data while it is stored and sent. Even if the transfer or storage media gets hacked, the encrypted data is mainly worthless to unauthorized parties without the right decryption keys. The second one is ensuring the integrity of data. Integrity in the security environment refers to the accuracy of information management and associated information. When a system is integrated, it indicates that the data is transported and handled in controlled situations. The data remains unchanged even after it has been processed. To maintain data integrity, hash function techniques and message digests are used in cryptography. The receiver is ensured that the data obtained has not been inferred during communication by giving codes and digital keys to confirm that what is received is legitimate and from the authorized sender. Assuring the right sender or receiver. Cryptography ensures that the transmitter and receiver's identities and the available information origin or destination are correct. Authenticity is only feasible through a unique key exchange that the sender uses to verify their identity. Usually, a login and passcode are used, although contactless cards, iRetina, voice commands or fingerprint scan can also be used. Non-repudiation holds both the sender and the recipient responsible. Non-repudiation refers to the affirmation of a transmitted communication. This concept assures the receiver cannot deny sending information by employing digital certificates to prohibit the sender from disputing the data's authenticity. Ensures data availability. Cryptography also contributes to data availability by providing that only those with the appropriate permissions may access networks and recover information reliably and timely. Robust cryptography solutions are needed to maintain data security. Cryptography can help protect your intellectual property from cyber threats. Types of cryptography. Generally, there are three types of cryptography. Symmetric key cryptography. It is an encryption system where the sender and receiver of message use a single common key to encrypt and decrypt messages. Symmetric key systems are faster and simpler, but the problem is that sender and receiver have to somehow exchange key in a secure manner. The most popular symmetric key cryptography system is Data Encryption System or DES. Second one is hash functions. There is no usage of any key in this algorithm. A hash value with fixed length is calculated as per the plain text, which makes it impossible for contents of plain text to be recovered. Many operating systems use hash function to encrypt passwords. And the third one is asymmetric key cryptography. Under this system, a pair of keys is used to encrypt and decrypt information. A public key is used for encryption and a private key is used for decryption. Public key and private key are different. Even if the public key is known by everyone, the intended receiver can only decode it because he alone knows the private key. This module provides an overview of cryptography, which is an art of securing the message by some means of transformation. As there are many analysis techniques, only a minimal percentage of ciphertext competes with an encryption cracking method's ability to work effectively. An encryption algorithm must be regular for it to be algorithmic and for cryptographers to be able to remember it. But the regularity gives clues for patterns, which gives clues to the cryptanalyst. In theory, it is an unsolved dilemma. The cryptographers invents a new encryption algorithm to protect a message, but the cryptanalyst studies the algorithm and to find the patterns and weaknesses. So, a principle of timeliness can be applied with security mechanisms. Data with short time value can be protected with simple measures. In the coming modules, we will see the different substitution and transposition techniques to encrypt the plain text messages to ciphertext. So, we will meet again with different algorithms for cryptography. Hope you enjoy this session. See you next time. Bye.